as to what is coming here. So this is the statistics unit 3 sampling and experimental design unit schedule. So as things are as of this moment, of course, all dates are subject to change depending on any kind of craziness we run into between now and the beginning of November. And so as far as homework, so remember that the unit 1, unit 2, first 9 weeks stuff is closing basically this evening or late tonight. And so that's your priority. If any of that stuff is still missing or needs to be retaken or whatever, that's what you need to do first before you worry about anything in unit 3, because there's no due dates for unit 3 until we get to next week. And so the first thing that's due is that very first homework, simulations homework number 1, that's due on the 19th of October. So that's when your first homework is due. So you guys have got like a whole week and like a couple days, all right, for unit 3 stuff. So you'll notice on there we have a simulations quiz right before that. I want to review how to do simulations on Friday during class. So I know we kind of introduced it a little bit last time, and I wanted to give you guys a chance, if you were all caught up, to kind of do the homework. So that's the first pages in here to do the simulation homework, just so I know where you guys are getting confused and where you have questions. Then I can go over stuff. So I want to kind of review a little bit next class on Friday. I'm not going to do it today because you would forget it all anyways. So that's kind of the plan. So we'll have our quiz on Thursday, the 15th, and then we'll have the homework for that simulations will actually be due after. So it's actually Monday, the 19th. So you almost get like almost 2 weeks. We're close to that. And then you'll notice in here, we're going to introduce the project on Friday. It's just introducing it. Like we're going to talk about all the details and stuff. So I won't have all that information until Friday anyways. But that's one of the things we're going to work on during this unit. And then don't worry about A day only. Like this quiz does not apply to you guys because you're my B day students. So we're going to do it earlier. What else is the due date? And then there's another break again all the way until like the 28th when more things are due. So that's when the rest of your worksheets are due, 1 through 3 for sampling design and 1 through 4 for experimental design. So I'm kind of circling like days things are due. So if you're finding that you have a lot of homework in one night, then you can skip and do one class one night, one class the other. Just don't save everything from my class till the night before, and you won't have like 4 hours of stats. So just make sure you're evenly spreading it out. Also remember, in the background as these things are going, we still have Albert IOs and free response questions and textbook stuff as well. So again, if you're waiting till the night before to do all these things, then you're going to make it much harder on yourself than you need to. But communicate with me if you're having difficulties getting stuff due by the deadline. I talked to some students yesterday in tutoring that said they had like 4 tests in one day. I was like, well, you got to let me know that that's going on so that I can, find a solution to help you out. I can't always promise that I'll make a perfect solution, but obviously studying for 4 AP tests in one day is not going to be very good for you because you're going to have like all this other information in your head. And I promise I don't meet with your US history or, whatever teacher and your physics teacher and everybody else and say, hey, what day can we give Connor like 6 tests? That'd be fun. So if I can help adjust it a little bit, you got to let me know. All right. But you can't let me know like the day of. You got to let me know like, hey, Mr. G, I'm looking ahead on the calendar in like 2 weeks. I'm going to have like 4 tests. Okay, cool. Let's work on something specifically for you that we maybe can find a solution or whatever. Because I know it's crazy right now and you guys aren't just doing school. You're trying to live life and all this stuff as well. So anyways, keep an eye on the due dates. So I'm giving you advance notice when I'm doing things. I know your other teachers may not be doing that. So take advantage of my generosity and pay attention to the due dates. So everything is pretty much going to be due, the rest of the stuff, the day of the test, which is the 5th here. So that's Albert IO. That's this other simulations homework we'll do at the end of the unit. That's the textbook stuff. All of that stuff is in. So if I wait till the 3rd to start it, then I'm going to have a butt ton of homework on that day. If I do a little bit throughout the unit and practice things as I go, it's a lot easier. So that's what I'm trying to get you guys to see. Like, just because I don't put the due date right in front of you doesn't mean that it's, you can't start working on it. So all the stuff is already open in Canvas. The only thing that's not ready yet is the Albert IO because we're still putting that together. And then I'm going to make a Canvas like assignment reminder so that people can remember that the Albert IO stuff is due, especially Zoom people, because I think you're sitting at home and you're like, oh, he said that once, but I forgot to write it down. So again, I haven't been taking too many late grades just because of all the chaos and the confusion. And plus, who knows what the schedule is going to look like in a week anyways. But I just want to go over this real quick at the beginning as people are coming in. So you guys can see that if you have this in front of you, your main due dates are like the 19th, the 28th, and the 5th. All right. We have a practice quiz on the 28th, and the word practice is next to it because we're going to go over it the next class. So we're trying to help you guys out, not take grades on every single quiz and assignment as we're going through there. If you got questions, make sure you're emailing me, messaging me in Canvas or whatever, And I tried to respond to those within 24 hours as much as possible. All right, let's do our notes thing here. So last class, we talked a little bit about simulations, and that's where you get the, you got to set up your simulation where numbers represent different things. And then we kind of went through and practiced a couple different simulations. So we did, on number 4 here, we worked 100 trials of a family of 3 and tried to figure out how many girls we would expect on average. And so I got it started for all the classes. When you're writing your simulations and you're practicing going through your homework, you want to be able to express what all of your things, like you kind of describe or set up your simulation for people to follow. So like for this first one, we said we select 1-digit numbers to represent children. We let numbers 1 through 3 represent girl and 4 through 6 represent a boy. We selected 100 families or trials, and then we counted, we were only counting the number of girls we got. So you need somewhere on there kind of like those 4 steps that were in your notes as you're going through it. If you want another example of that, I can show you the example on number 5 as well. So I don't know if everybody was online or if we had the notes printed off or anything that day, then you need to look at that and then you can. My goodness, people emailing me like crazy. All right, and then like I say on the other one here, the steps, same thing. This is the one with the actual numbers. So again, we said let 1-digit numbers represent children, let the even numbers represent girls, let odd numbers represent boys. We selected 3 families for our trials, and we counted the number of girls. And that's what we did. I'm just basically describing the steps. So if Connor was to come by later, he could follow my instruction. All right, same thing for the poor Alex and her blood sample. Select 2-digit numbers to represent blood type. 00 through 06 equal O negative blood. 07 through 99 equal other blood. And we continue selecting 2-digit numbers until O negative is found. And then the number of trials in this one are going to be recorded, not actual how many O negatives we got. Once we find an O negative, we're good to go. All right, so that's what we did last time. So if you got any questions on those still, you guys know where I'm at. Again, please, please, please keep on asking. If you haven't figured it out already, I love the questions. All right, so let's talk about sampling design today. Like I said, you will eventually need a device, especially those of you guys in class, to do our activity. So if you don't have one, I got you covered. All right, so sampling design, unit number 3. Let's rock and roll this thing. So we've talked about simulations where you can kind of pretend like the event is going on and make predictions or indications based on your sample. Now we're going to talk about actually designing a sample in order to gather data in the most efficient way possible. So in order to understand why we do that, let's go back in reverse for just a minute and review how do we, as a statistician or a math person or anybody in general, gather data. So I'm on the next page in your notes. Part 2, sampling design. How do we gather data? So the easiest way to gather data is to look at just surveys and interviews. So if I want to find out your guys' favorite whatever, I just go around and ask you, what's your favorite ice cream flavor? What's your favorite ice cream flavor, et cetera, et cetera. So doing a survey and interview is a great way to get information as far as data gathering. We also look at studies. So things that are observational, like if I just happen to watch and say, okay, on average, how many people show up late to my class? I can just make a study on that. Everybody that walks in after the bell, make a count for it. We can do retrospective studies where we go back and look at things that have already happened. Right? This happens a lot in sports and medicine, like what kind of things did what in certain scenarios. Can we expect that to happen again? We can also look to the future and make guesses on prospective studies and anticipate trends and that kind of stuff. And of course, the all popular one, we can actually run an experiment. And that'll be the second part of unit 3, where we design proper experiments so that we can finally say this A causes B to happen. All right, so that's how we gather data. When we're gathering data, we are trying to look specifically at the population. And that's the entire group of individuals that we want information. So this is a review from unit number 1. All right, so populations can be any size, but they represent the entire group that we care about. So if it's just me surveying my students on how well or how poorly I'm teaching class, then my population would be Mr. G's students in AP classes. That's it. If it's a question about how high school students at Allen think about whatever, then the population becomes Allen High School. students. If we're worried about what the city is going to vote for as the new mayor, then it becomes the city of Allen's population, et cetera, et cetera. So populations could be any size. It just depends on what do you care about? What are you trying to find information about? Now, to find that information about a population, you do what we call a census. Again, this is a review term from Unit 1, but a census is specifically a complete count of the population. It can be used to gather other information as well. So the neat thing about learning this year, sampling design, experimental design, and surveys and all that stuff, is we're in the time of year where this is actually relevant to our real life, right? We got an election coming up one way or another. We've got coronavirus and statistical studies on that. So we're going to get to see like what are some proper methods and ways to determine outcomes about stuff that we actually don't know. We're also living through a census currently. So every 10 years, this country does a census. And so if you're not aware of that, ask your parents or guardians, did we do a census this year? For us, it was digital. If you were able to do it by a certain time. So I just logged onto a website, typed in my name, my wife's name, our 2 kids, how old we were, boom, and we were done. It's actually kind of nice this year. In the past, it's been like a little booklet and you got to put in there like how many times a day you shower and like they want to know everything. Now they just know that because I got a smartphone and it records everything I do. So now they don't have to ask those questions anymore. Like we know what you do in your house, Mr. G. Which I'm like, fine. I'm boring anyway, so follow me. All right, so how good is the census? We're gonna do the frog fairy tale activity. So you're gonna get 3 minutes. Don't start yet. You're gonna read the paragraph that's in the notes. I'm gonna put it on the screen for people that don't have the notes printed off. And what you're going to do is read the paragraph, and you're going to be an auditor that's looking for the malfunctioning letter G. All right, so it can be capitalized G, lowercase g. It can be at the beginning of the word, end of the word, anywhere inside the, try not to look at the numbers. Don't look at all the guesses. Good job, Mr. G. Spoiling the fun. There we go. All right, so what you want to do is read this paragraph here and count how many letter G's there are in that paragraph. So I'm going to put my little watch clock thing over here on 3 minutes. I'm going to tell you guys when to begin. And whatever method you want to employ, count those letter G's, ready, set, begin. You're doing the census. All right, you got about 1 minute left. And time. So I'm going to ask the class, and people on Zoom, you can type into the chat box, how many letter G's did you find? So here's answers we got from 0 period. You guys hit me up. What do we got? 83. All right, that one's already on there. 83. What else? 77. All right, very good. That one's on the list. Any other numbers that I need to add to it? Don't be shy. 75. I see. Ooh, we're going fast all of a sudden. Hang on, I'm checking. All right, so 77, 71. I'll add that to the list. Very good. We got 75. 79. It's okay. I'm blind too. I don't have my glasses on, so I could be completely, writing whatever. 75. That's probably why people look at me weird when I'm doing stuff. All right. Any other numbers on the list that I need to add on there? So right away, what do we already see as a problem with the census? What's that? Yeah, they're all different, right? So if I needed to be like 100% sure that the number of G's on here is accurate, I'm already like in big trouble if I rely on you guys just counting it. So the actual answer, some of you guys did guess it, is 83. So very good. You got 83. Yeah, 75's on there twice. That's okay. 75 is really cool. Someone put on it twice. So the actual answer is 83. And I know some of you guys probably just went highlight paragraph, look for G in it, and you just add them up on there. So that's fine. I said use any strategy you want to do. So I didn't say that you could or couldn't do that. But if I wasn't sure that the actual number was 83, what would we typically do again in order to make sure we have the right number? We'd count it again, right? And then if we got numbers that were closer, okay, we're almost there. Let's count it one more time. So what's happening each time I'm counting it is it's not always accurate, number one. So why would we not want to do a census all the time? Well, we just saw accuracy is terrible. All right, number two, it's time consuming and possibly expensive. So if Laura and I were trying to figure out the letter G and we had to keep recounting it, 7, 8, 9 times, it's going to take us, 30, 40 minutes to do it right. And then if they keep coming back and saying you need to recount it again, we're not sure. Eventually, we're going to want money for our effort. So the people that are paying us, it's going to cost them money to do it. So not always accurate, very expensive and time consuming, a lot of times impossible. So that's number 3. All right, so counting the number of fish in Lake Louisville would probably be an impossible task because things are changing, moving. How do you know you didn't catch that fish? You got to tag them all. Like, what are you gonna do? And number 4, this one's kind of important because a lot of industries have to consider this when they're doing sampling. If you're using destructive sampling, you would destroy your population. So what I mean is, say you wanted to know how strong your soda bottle is. Well, if you sit there and try to destroy them all because you're doing a census, you have no soda bottles left to sell. If you want to test how long your battery is compared to the Energizer Bunny, because it keeps going and going and going, well, the only way you can do it with the census is you have to use all of your batteries that you make. Well, then if I use them all up, then nobody's going to buy them because they're already out of juice. So I would destroy my product in the process of doing a census on it. Safety cars for ratings. I got a brand new Ford Mustang model I want to sell. So let me see how well it does when I crash it against the wall. But I'm going to do a census. So I'm going to crash every Ford Mustang that I make so that I can be 100% sure. Oh, wait. I've got none left to sell, so it doesn't matter. So that's why we can't do a census all of the time. That was kind of the main point of this part of the notes here. Because a lot of times students, in general population will think, well, why don't we just go out and count the people? Why can't they just tell us what the information is and then we'll go from there? It's not accurate. It's a lot of times impossible. And if it's destructive, then we just would be wasting our product in order to do so. So instead, our solution is, instead of taking a census, we go ahead and deal with a sample. All right, so a couple of things, examples up here they put on there as well. Look at the US Census. It's a huge amount of error in it, plus it takes a long time to compile. So they're going to take this whole year just to count everybody in the country. And then by the time they sit down and look at the data of 350 million plus of us living here, it's already going to be obsolete because people are going to have died by then. New people are going to be born. People are going to move. And so what they're going to look at in the next 3 or 4 years from the census is already going to be inaccurate by the time they care about it. That's why they just, bug your phones and let's do it that way. All right, suppose you wanted to know the average weight of white-tailed deer population in Texas. Would it be feasible to do a census here? No, because I would not know which deer I have and haven't counted unless I tag them, in which case I'm destroying the population because they're no longer being left alone. All right, so here we go. Let's talk about samples. That's what this whole unit is about. So obviously, Mr. G, we can't count everybody all the time, every time. So instead, what we're going to do is a sample, which is just a part of the population that we actually examine in order to gather its information. And then based on what our sample looks like, we make a guess or inference back to the population. Which leads us into a whole new area of problems. How do I pick the right sample so that it actually represents the population? I can't just pick my favorite friends or the people that I like to talk to because they don't necessarily represent everybody. Maybe they do, but not necessarily. So taking a sample to find out information about the population, using that sample to make a guess or inference about the population. But again, we have to make sure we do it the right way or we're going to be in trouble. All right, when we're talking about samples, there's two main components to the sample. Number one is the design that we choose for the sample, so sampling design. And that is going to be basically the method that we choose to use when we're taking our sample. So there are four main methods we're going to talk about in statistics this year. And if I'm going too fast, just let me know, guys. I can always go backwards. We're going to talk about four main types of samples: simple, stratified, systematic, and cluster. And so depending on which one of those you pick, that's your method, that's your sampling design. And so it's important as we're doing our samples to think about the outcome we're going to get from our sample. And if we don't do it the right way, then the data that we're going to use is going to be wrong, and we're going to make bad decisions either on purpose or accident from our bad data gathering. And so today we're going to discuss how to build and make the samples the right way. And then on Friday, we're going to talk about one of my favorite topics, and that's bias and how your samples could be wrong and how things go crazy because humans are messy people and they don't do things right. So I enjoyed the Friday lesson a lot, and I think you guys will too. It's very relevant to, I say, a lot of stuff that's going on in real life. So we can have fun with it. All right, and then in order to create my sampling design, sometimes I need something that's called a sampling frame, and the sampling frame is basically just a list of every individual in the population. Sometimes this is possible and available, sometimes this is not, which will cause us to have to do different sampling methods if we have access to a sampling frame or if we don't. So if I wanted to survey high school students here at Allen, I have a sampling frame. It's called your guys' registration in Skyward. I just need them to print off a list and I know everybody who's at the high school. If I'm trying to do a sample of like fish or deer, in the natural parks, I don't have a sampling frame. The fish don't get together and make a registration of how many little fishies there are. And I can't use that to randomly select little fishies. So sometimes you have the sampling frame, sometimes you do not, as far as what you're available to do. All right, so with these three things in mind, let's talk about the four different sampling types. Number one, a simple random sample. So for all four of these designs, the key word in all of these things is going to be the word random. So if you want to highlight that word as we're going through these definitions, I would suggest you do so, because if your samples are not conducted in a way where it is random, then your sample is technically not good. It's pretty much garbage. So the word random is going to be either in the title or the description or the process somewhere in all four of these things. So simple random sample, this is the easiest one to do. This is where every individual in the population is chosen in a random way in which two things are possible. Number one, everybody in the population has an equal chance of being selected. And number two, every possible group that I can make, okay, so say I'm selecting 10 individuals, then every group of 10 is also equally likely to occur. So we have like 30-something students in this class. If I wanted to do a sample of 10 in order to find out if you guys, think I'm doing everything I can to help you out for like whatever, and that's my question. I just want to know, but I don't want to spend the time asking all 33 of you. I just want to interview like 10 of you. Then if I did a simple random sample, everybody in the class, even those at Zoom or in the person, would have the same chance of getting picked for my survey. Also, every group of 10 students that I interview has the same chance. So I could, in theory, pick all 10 students from the Zoom if it randomly comes up that way. So that's just as likely as picking a mix in both, or all 10 of my students coming from the in-person portion of the class. So it's just random, all right? And we're going to talk about how to set this up and how to guarantee that we are actually randomly selecting people, because just using our best judgment for random doesn't work. There has to be some sort of method behind it, and that's what we're going to be talking about. All right, the example that's going to be on the notes slide, it's the one that's printed in your notes here, is dealing with a survey that we're trying to conduct at the high school. So suppose we're going to take a simple random sample of 100 high school students. This is what's at the bottom of your thing. We're going to put every student's name in a theoretical hat that goes to the high school. Okay, so obviously I don't have a big top hat from the early 1900s, late 1800s, that I'm just cutting sheets of paper and putting it in there. But we're generalizing and saying that everybody has the same chance of being picked. I'm going to randomly select 100 names from the hat. Okay, so I'm randomly pulling names out. Since each sheet of paper is the same size and everybody's in the hat equally, then each student has the same chance of being selected. That's the whole point of this process. Now, I have to be careful because depending on the type of question I want to ask high school students, this could be a good thing or a bad thing. So say I want to convince the admin that we need to have an hour for lunch, not 30 minutes. 30 minutes is just too short. We need time to get to the lunch thing, or not just an hour. Heck, let's have off-campus lunch too. Like, we don't have to serve everybody in the cafeteria, right? We got people that can drive. So in order to convince them that the student body thinks that's a good idea, I'm going to interview 100 students. But I got to do it randomly. If I only pick the students I know for sure that are going to say yes or no, then I'm not conducting a good unbiased sample. And so I put everybody's name into a hat and I draw them out randomly. The problem is I could get 100 students that are all seniors. And if we're not going to be making the changes until next school year, then the seniors don't really care what we do because they're not going to be here. So they're going to be like, no, you should not have. In fact, you should only do 15-minute lunches because sophomores and juniors screw around too much and we should punish them. Vice versa, I could accidentally pick a group that's all made of sophomores and they're like, no, we should have a 2-hour lunch and a nap every day. And the seniors are like, well, that's not fair. We never got to do that. Now school's being conducted differently. So that could be a potential problem if I just do everybody at random. So if that is a problem, then we might have to pick one of the other methods. All right, but in this first one, every student has the same chance of being selected, as well as every group of students has the same chance of being selected. Notice I didn't say the juniors because they're like the middle child. We always forget them. Sorry, junior. We love you. All right, so again, not only does each student have the same chance of being selected, but every possible group of 100 students has the same chance of being selected. Therefore, it's possible for me to get 100 students that are all seniors, and the seniors are like, nope. Don't do off-campus lunch. We never got it. It's not fair. Give them only 15 minutes. Make them sit in their classrooms. They don't get to talk to their friends, whatever, right? Because you just don't like the sophomores and juniors. They're not your friends, so you got to do the upperclassmen thing and punish them. That's good. I was not a nice senior. Okay, so if that doesn't work, is there a solution? The answer is yes. Our next example, stratified random sample. So with a stratified random sample, we're still picking names out of a hat and everybody still has the same chance of being selected. However, we do a little initial step to make our lives a little bit easier. We take our population that we're going to be randomly sampling and we divide them into homogeneous groups to begin with. So groups that have alike and common characteristics get put together. So in this case, using my example, we put all the sophomores in a group, all the juniors in a group, and all the seniors in a group. These groups are called strata, and that's where the name stratified random sample comes from. Once everybody has been grouped based on like characteristics, then we randomly select from each group a smaller number, and then we add it all together, and we have a total group at the end. So for this one, if I was going to do my previous example, then I now have maybe 50 kiddos from the sophomore group, 50 from the junior group, and 50 from the senior group. So my final group is now 150. But in that 150, I'm guaranteed to have a little bit of everybody. So now the seniors are like, nope, no extra lunch for the next guys next year. It's not fair to us. Sophomores are like, please, please, please. You know, we need 3 privilege periods, whatever. And so we can have now a nice, even discussion from all facets of the building and not just one group influencing the final decision. So this is a more evenly distributed, more diverse way in doing your sampling, if that is necessary in what you're doing. If it's not necessary, then you don't have to go through the process of putting people in the group first. So it depends on your scenario. So here's the example. Again, it's at the bottom of your notes already. Suppose we're taking the stratified random sample approach. Now we're going to do 150 students. Since the students are already divided by grade level, we're going to use that as our strata. And then we're going to randomly select 50 seniors, juniors, and sophomores. So now my final group is guaranteed to have a little bit of everybody. And if that's important for me, I'll do this method. If it's not, then I don't need to waste my time putting people in the groups first. So this is not a one size fits all type of method. That's why there's multiple methods here, because every scenario is a little bit different. But the goal is, or the key is on all of these, notice the word randomly selected, like that word random has to be in there. I can't pick my favorite, I can't pick all the, popular kids or whatever. I need to make sure I randomly pick it. All right, if we're unable to figure out the total population, all right, we can't really look at the sampling frame and see everybody that's going to be a potential candidate for my sample. Instead, I could take an approach of a systematic random sample where maybe I don't know how big my population is, but I still want to randomize as much as possible who I'm interviewing. So with a systematic random sample, what you are doing is selecting a sample by following a more systematic approach. Typically, this involves you selecting a number between 1 and say like 20 or 1 and 10 or something like that. And then as that person approaches you, okay, you're in an area where people are moving around or doing things, you interview that person, all right? So if I pick number 12, then I'm interviewing the 12th person I happen to see. And then I'm gonna interview every, say like 20th person after that. So, all right, hey, Connor, nice to meet you. How was your day at Six Flags, whatever. He starts telling me things and everybody walking by is like, why didn't they pick me? Well, Connor was the 12th guy I saw today. I get his information, I walk on, and then I go to the next person 20 people away. So the 32nd person I see today. Hey, Laura, nice to meet you. How was your day at Six Flags? Let me get all your stuff. And she said, why are you picking me, Mr. G? I want to go home, man. I don't want to talk to you. You're the 32nd person on my little clicker here. You're a lucky winner, okay? So it's a very systematic approach to where it doesn't matter who the person is. It doesn't matter, their opinion or anything like that. It just happens to be they're the next number up as you're counting people walking by you. Okay, this is also the same approach they tell us that they use at the airport for the random screening process. All right, so they just have a number and like, all right, Aman, you're the guy that got number 76 today. Come on with us. We're taking you over to the body scan. Aman's like, why, man? I'm gonna go into my soccer match. What you messing with them? And so, anyways, that's the method they tell us that they do. So suppose we want to do a systematic random sample of high school students, we would number a list. Try to get an idea of how many students we have, just a rough estimate. And then say there's approximately 2,000 students on campus at any given time with privilege periods of people leaving, going, all that stuff. And I still want to do a sample of 100 to ask about, off-campus lunch next year. So I'm going to take 2,000 divided by the 100 students I need. And I'm going to say, okay, between 1 and 20, I'm going to pick somebody. So I randomly select a number, rolling a dice, using a random number generator or whatever. And the number comes up to be number 12. And then I'm gonna say, okay, the 12th person I see in the main hallway today, that's who I'm interviewing. So I walk down the main hallway, hey, you're number 12. Let's talk. Should we have an off-campus lunch? Should it be an hour long? Yes, no. And then I let everybody go by, and then I start counting again. And when I get to the 32nd person, because I'm gonna count every 20th person, then I talk to them. And I keep going until I get 100 people. So it's random because nobody knows when you're gonna be there at what time. Say if Connor decides to go use the restroom, then I don't interview him that day. So it's a random thing. So the word random is still being used there. So that's systematic approach. Again, this is very useful if you don't know the entire population size you have. And so instead you're kind of estimating about where it's at, and you're still making it as random as possible because we don't want to show favoritism in our samples. All right, last approach. Suppose that this is not possible just because of chaos or craziness. Then the last approach we have is called a cluster random sample. So this is not randomizing who I talk to. This is randomizing where I do my survey. So I randomly pick a location or a few locations, and then I sample everyone there. Okay, so I'm less concerned about randomizing the individual, and I'm more concerned with randomizing the location. They use this one all the time for election day polling. You just happened to be there when they did the, hey, who are you voting for question. They didn't really care who you were. It was randomly based on location. So if they call your house on the phone, they walk the block and ask who's going to win the next, mayor election in Allen, whatever. It's your location that got you picked, not your individual status. So looking at our high school example one more time, suppose we want to do a cluster random sample of high school students. The best way to do this would be to randomly select about 10 classrooms during, say, second period. So I'm not worried about the school giving me a list of all the students. I want a list of, how many second period classes do we have going on? Sweet. I'm going to pick 10 of them at random. I'm going to go to that classroom. So the first one I pick, F220. I'm going to walk all the way upstairs, go to F hall, knock on the door. Hey, I need to ask everybody in here what their opinion is on having an hour-long lunch. Are you in favor or are you against? So everybody in the classroom is my sample. The location was what was random. And so that's how you would do that one. All right. We're going to do an activity where you guys actually get to practice doing this stuff with hands-on fun here. So before I move on, any questions or any definitions I need to go back to review or talk about? Are we okay? All right, so this is where you will need your computer. I know people at Zoom obviously have theirs out because they're looking at me. In class, if you don't have your computer going, you'll need to get it going because we're going to do a Peer Deck activity. And so you need to be able to log into my Peer Deck activity to put in your answers. So if you need a laptop or yours is not charged yet, then let me know. I have some extra. All right, so we're going to do what we call a jelly blubber activity. So they're little jellyfish looking guys on sheets of paper, but I made it digital this year for safety purposes. So we're going to select jelly blubbers and we're going to use them to predict what their actual average length is of their population. So I'm going to load up the Peer Deck thing. I'm going to explain the process. I'm going to show you guys the random number generator again that we used last class. And yeah, it'll be something different that we're not sitting there constantly staring at the screen and watching me take notes. You betcha. There you go. You bet. All right, it's syncing up my presentation. Yeah, log in as me, of course, the crazy thing. There's my... All right, so on your screen, you will see once it initializes, a join code and a website for you guys to participate in our nice, fun Peer Deck activity. If you've never done Peer Deck before, it's kind of a neat little interactive thing. If you have, then you know what you're in store for. It's like basically Google Slides with space for you guys to type in answers and feedback. So go to joinpd.com. It's this website right here. And type in these crazy letters, OVUZZB. Orange, violas, usually zip, zesty bandanas. There you go. All right, so get logged in, take a minute. Just if it's asking you to register or do anything fancy, use your school email. You don't need a bunch of spam sent to your email you care about. Let your school email get filled up with garbage. They shouldn't spam you, but in case they do, don't give them your nice email. So it's all through Google, so it should say just click on that and you're logged in. All right, so let me give everybody a minute to get there. People at home, same thing. If you're having difficulties, let me know. Joinpd.com. OVUZZB. All right, still got a few more people getting logged in. I got 25 and we have a class size of about 30 something. So another minute or two, get logged in. All right, everybody in here good to go? Anybody still logging in here? Zoom, we good? There we go. There's that last person I was waiting on. Very good. All right, so click on, before we go anywhere, this little PDF link right here, and let me kind of explain all of the little slides you're about to see. So you're gonna have a different tab open, but this PDF is gonna be everything that you need So here's your little happy jellyfish that we're going to be looking at. So they all have different sizes. Some are really tiny, some are medium sized, and some are large. And our job is to figure out what their average length is. Okay. And it's not in like units or anything. So we're just trying to figure out the actual measurement of these little jellyfish. So you could do a census and try to sit here and measure all 100 of these, but that would be time consuming and not fun. So what we're going to do is do samples of 10 of these little jellyfish and use their average to kind of give us a best guess of what the actual population average is. So we've got the green sheet, which has them all just randomly on there. We've got a yellow sheet, which we'll use in a minute, where they're already grouped based on size. And we have an orange one where they're grouped based on location. So that's going to help us with all of our different sampling methods. For right now, we're going to want to use the green one first. The very last page is a list of all of their lengths. So how this works is if I go and look at the green page and say I want to know the length of number 84 right down here at the bottom, then number 84, if I go down here to the chart, all right, the number for number 84 is right here. He's 42 in length. Again, it's not units, it's just a number. Okay, so you might need a calculator to add up 10 numbers and divide by 10. That's really the only thing. Your computer should be able to do it. And then if you're in class, I can go grab them for you guys here too. But you just need a very simple calculator that's able to add 10 numbers and divide by 10. So the very first one we want to do is the judgmental one, meaning you're not going to employ any sampling method. You are going to just simply make your best guess. So if you haven't already, click on this link to get your PDFs up. And then I'm going to go ahead and move to the next slide. If I need to go back, message me, Zoom people, or in class, you guys shout at me. All right, so for our first sampling method, you're going to use your best judgment. So no randomization, no specific technique, just you pick your favorite 10 jellyfish on there, jelly blubbers, whatever, and write down what their lengths are, and then do your average. So I go back and I look at my little green sheet, and whatever 10 I think best represent my population, that's what I'm going to use. And there's different strategies. You can do all the middle ones. You can do some big ones mixed with some small ones, whatever you want to do. You make your best guess using no specific method whatsoever to guess 10 and then go from there. So that's the first thing you guys are doing. When you are done, if you go back to the Peer Deck activity, you should see on the right side like a little bar to type in a number. That's where you put your final average after you figured out your 10 links, added them all up, and divided by 10. All right, anybody here need a calculator? All right, cool. All right, so as I start to see responses come in, we will move on. So I'll give you guys as much time as you need to. Again, any 10 that you want, no specific requirement whatsoever. Got our first response in. Thank you, thank you. And those of you guys that have printed off your notes, there's a nice little chart that you can kind of keep all this stuff organized if you flip the page. So we're doing number one, the judgmental one. So I would write down which jellyfish I was looking at, and then I can go back to the chart all at once and actually put all their links here, add them up, and then get my average in this little box. So this last number is the one you want to type into the Peer Deck activity. Yeah, no problem, Elliot. That's fine. Just type it into the Peer Deck thing. That's a good answer. No problem, sir. All right, got about 2/3 of the responses. So those of you guys still figuring out your answer, go ahead and do so. Type it in once you get it. I got 17 out of my 28. No, you can, that's no fine. You get like 23.6 or something like that. 19. Okay. All right, so got about 8 people need to finish typing in the replies. So I'll give you guys about a minute, maybe 2. Pick your 10 favorite ones that you think best represent the population, and let's see what we get. And again, no actual statistical sampling method was applied here. You just picked which ones you like. Okay, so this would be like me going to the hallway and picking students that I find easy to talk to, favorable, whatever. Using my human judgment only and no actual method to randomize my process. Whew. All right, so what I got so far, there's only like 1 or 2 that haven't turned it in yet, and I know one of my guys is in the restroom, so we won't wait on him. So there's kind of our graph right here of your guys' responses and replies. So I have anywhere from 7 all the way up to 26 as a guess based on what you guys sampled as. And then our average is coming out to be pretty close to 20 on this one. Okay, again, this is just your guys' judgment based on which ones you hit. So obviously some people pick the bigger one, some people pick smaller one. It happens, right? There was no system involved. And so there's a large variety in between the type of guesses I'm getting. There's a lot clustered around here and here, but in general, I'm kind of all over the board. So right now we're saying our average could be possibly anywhere from 7 to 26 with numbers close to 20 more likely. Okay. So again, we're just eyeball testing it. Some of you guys use different strategies and that's fine. So now for the next one, what we're going to do is we're going to go back and look at the green sheet, but we're going to randomly select them this time. So the first time you got to pick your favorite ones. On the simple random sample, you are going to be randomly picking them. So you get to use our random number generator again website. So if you click on the little orange link here, it's going to bring up the random.org. And then it's already set up for us here in the box. We have a random number generator from 1 to 100. There are 100 jelly blubbers, so this is perfect. So basically just press this button 10 times and write down on your second row of notes here what 10 numbers came up. So you're going to press that button 10 times and fill out this row here with the random 10 numbers you got. Then go to the chart and then look at that first chart and write their links underneath, add them up and do your thing. So it's going to be completely random this time. You will not get to pick which ones you do. The random number generator will do so. So again, I generate it. I got number 59. So I go to my chart here and I would write in 59 and keep going 9 more times. And then once I have my 10 numbers picked out, again, go back to your PDF thing, go down to the last page and then write the links underneath it. All right, go for it. See what you get. I'll put this back up here. Again, there's a spot to the right to fill out your answer after you've added up all 10 numbers and divided by 10. Now, as you guys are doing this, remember every jelly blubber fish thingy has the same chance of being picked by your random generator. Okay, so you're no longer given it the eyeball test, it's just randomly being picked. So every little jellyfish now has a chance, whereas before maybe you were ignoring some of the different sized ones for whatever reason. Also, every possible combination of 10 has a chance of being picked here. So in theory, Laura could randomly select some of the 10 bigger ones because she has no say in it, right? It's just randomly happening. Just like Claire could randomly select 10 of the smaller ones. She's kind of stuck with whatever the random number generator gives her. She's no longer putting her own judgment onto which ones are getting picked. So that's a negative or a positive, depending on how we look at it. So we'll look at the graph and we'll compare it to the first one and see, did we shrink the graph down? Because we want as little variability as possible. Why? Because I want to be as accurate as possible with my guesses, right? So if we do enough of these samples, we would want it to be, we want the graph to shrink in. So it's not like between 7 and 50, it's now hopefully like smaller range of numbers. Because again, I'm not able to catch all 100 of these fish at the same time and measure them. So I'm only doing 10, and I'm hoping that the 10 I pick are random enough that it's a good representation of the population. Which will start leading us into Friday's discussion. I'm excited. Friday's a good day to talk about it too. All the weird things that happen with your samples. All right, very good. Got about 6 more people that need to enter in their numbers. So 1 more minute for those last couple of entries, and then we'll look at the graph and compare it to the first one where you guys made a judgment call. All right, so let's look at this graph and let's compare it to the last one. So for this graph, my range is, somebody's typing in, so don't panic on that last one. My range is from about 15 to 33, whereas on the first one, the range was from 8 to 26. So I feel like the range has gotten a little bit smaller, just looking at the thing all together. And most of the responses now are clustered a lot tighter around that gray area, which is where our average is centered on. So we still have the same average of 20. All right, but here we had like dots. This is our first one. Dots were all over the place. Like everybody had guesses from way back here to here. Whereas this time they're all pretty close right here in the middle. We had a few people that got some very big samples, and that happens. Okay, so somebody got something bigger than 50, bigger than 33, bigger than 25. Like those are bigger samples. And we got some people that got some small samples down here by 15. But where this gray area is, we're getting close to what our actual answer is. So this is a different approach, but a completely random approach to sampling your 10 individuals. So now, how can we solve the issue that some people got really big jelly blubbers or got some really small jelly blubbers? That's where our next method is actually advantageous in this type of scenario. So the next method is a little bit more tedious, so I apologize in advance, but it's a lot more effective and accurate for what we're trying to do this time. So this is the stratified sample. So what you're going to do this time is use the yellow sheet to pick 2 jelly blubbers from each group. And so the yellow sheet looks like this. They've all been divided, into their size groups. So for this one, we have little ones here, kind of small ones here, medium ones on 3, bigger ones on 4, and the largest ones in 5. So you're going to pick 2 from each group. So where it gets a little tedious is with your random number generator. So the first group, I need to pick 2. My number goes from 1 to 19. So I have to go to my random generator, type in 1 to 19, and then I need to generate 2 numbers from here randomly. So, I get number 9 and number 15. So then what I'm going to do is write down for the first one, number 9, number 15 in my first group. If you want to put like a little spacer or a line there so you know that that's from group 1, because you're going to have the same numbers popping up again. So I got 9 and 15 here, and then do that for the rest of them. You have to readjust your random number generator for the size of each group. So for the second group, it's 1 through 17, and it's 1 through 19 again, and it's 1 through 23, and then it's 1 through 22. So you have to change your range on your generator, pick 2 each time. Don't leave it on the same one, because then you're giving numbers that aren't included a chance to be picked when they shouldn't be. So, and you can't just say, well, I'd ignore it. Well, then the other one's got a better or worse chance. So you're affecting the probability there. So make sure you're adjusting your deal. Then the chart you want to use this time is these 5 at the bottom. So for your first group, you use this one, second group this one, third group that one, fourth group that one, fifth group that one. So that's why it's helpful to put the little bar in between so you know which chart you're on and which one you're using. This one will take a little bit longer, so I apologize in advance if you now hate sampling methods because of this, but there it is. Give you guys 5 minutes at least on this one because it's a little more tedious. Work your way through it. Let me know if you got questions. Again, when you're done, type in your average. All right, very good. Got about 10 responses in already. Nice, nice. All right, very good. Got about 10 more people need to put their response in. We find the average of 2 charts. What you're gonna do is find the average of, you got 2 from each one, so you're still gonna have 10 numbers. And so as you're going through this, you should have 2 from the first, 2 from the second, 2 from the third, 2 from the fourth, 2 from the fifth. Each of them will have links underneath it, so you just add up all 10 of these links, and that would be your average right there. So it's still a total average of all 10. It's just they've been broken into smaller groups, so you take 2 from each group. That's all. That's really the only difference. So you're going to use these charts down here. Don't worry about this chart. Not on this one. So this is the page I'm looking at when I'm breaking them up into groups. All right, got about 2 more minutes. Got most of my replies in. Still got about 8 people. And while we're sitting here waiting, I did go back and look at that one question on the test number 18. I know you had a question on a couple of people. For some reason, it didn't save when I did it. So double check your guys' test stuff. And it should have gone up the points if that typo was accurately correct. Because I know Sydney and I think a couple other people were asking about it the other day. And I don't know why it didn't save for 5th and 6th. It only saved for 0 period. So I went back in there and fixed it. So I know Sydney's got fixed. I'm trying to remember who else in there emailed me. Anyways, thank you for reminding me because it wasn't just this class. It was 6th period too. All right, last minute, get your replies in. Got about 4 people left to submit their responses. I know this one's a little more tedious. The next 2 will be a lot quicker, but the results of this one will be easily evident when I show you guys the graph here. It's a lot better looking than the other 2. All right, so let's look at the graphs here. So with the stratified, like you can see night and day difference now, right? Look at all the dots and where everybody's located. Like we're all right now centered around an average of 18. Like there's very little variance or discrepancy in everybody's guesses. So the first one was, again, your guys' judgment, and all the dots were everywhere. And we had some really small, some really big, but there was not very much in the same. You guys just eyeball testing it. It got a little bit better when we randomized it, but it was still kind of diversified pretty decent. Like we still had somebody with a really large sample because they unfortunately got a set of jellyfish that were really big. And then this one, though, watch, like it's right there. So we're fairly confident now that our average is between 17 and 21. Like it's probably pretty close to 18, 19, somewhere in there. All right, and so I feel a lot better about making a guess about the average length of the jelly blubbers using this method than I do the other one so far. And that's because we're breaking them down into groups. So our final sample size is guaranteeing that there's 2 really small ones, 2 medium ones, 2 really big ones, and then a couple in between those. So now we're not going to end up with a sample size that's all crazy or skewed or whatever else. So again, the graph early shows you guys the difference in the method between you just taking your best guess versus randomizing it versus stratifying it first, then randomize it. So while a little bit more tedious, it does provide much more accurate and much better results. Now, the method is not always possible. Okay, sometimes I just don't know what groups to break people into. So I need to find other ways to randomize it that aren't just simple random. So we're going to practice our last 2 methods. Next one's the systematic sample. This one's the quickest one to do because once you pick your number between 1 and 10, you just add 10 to it. So go back to your random number generator, type in 1 through 10 here, and you're going to press generate, and you're going to get a number. So I got number 4. Somebody else might get this number too, that's fine. You need to pick a random number between 1 and 10 from this page. Then you're gonna go to your little note sheet here. We're on the systematic one. So if I put in number 4 here, I'm gonna do every 10th jelly blubber after that. I'm doing this systematically. So it's gonna be number 4, then 14, 24, 34, 44, 54, 64, 74, 84, 94. Connor, what number did you get me? So Connor's going to do 2, 12, 22, 32, 42, 52, etc. until he gets to the end. So there's really, if you think about it, only 10 possible outcomes here. Okay, so depending on whatever your first number is, add 10 to it. You don't even have to look at the jelly blubbers themselves. You can just go to the big chart again. Connor picked number 2, so his first length is going to be 5. Then he's going to look at 12s, 20 seconds, 30 seconds, etc. So every 10 after that one. So this one should go relatively quick compared to the last one, so I'll give you guys about 2.5, 3 minutes. Pick your number between 1 and 10, add 10 to it till you get to the end of your chart, record those 10 links, add them, average them, and type in your number at the bottom or to the side of this thing here. Let's see what our graph looks like. Systematic approach. It's random based on their number and when they run into you. Does it work, Connor, for filling it in? Because I know you like doing that. Is it okay? Like, the note's pretty flexible. You can type into them. And yeah. Okay, perfect. And I know some of you guys like filling it in, like your homework, you always turn in that way and stuff. So I'm glad it's working that way. Awesome. Last year, not so much. This year, we're good. Whew. All right, numbers are coming in, looking good, looking good. We got about a third of the people finished. Again, pick that first number between 1 and 10 and keep going every 10th after that. Why did I choose 1 through 10 on this one? For those of you guys that are curious, because this is something you need to know. So we want to survey a total of 10 jelly blubbers, and we have 100 to select from. So whenever you're setting up your systematic approach, you got to do a little bit of division at the beginning. So take your total population size or estimated population size if you don't know it, and divide by how big you want your final sample to be. In this case, 10. So that's where our 10 comes from. And so we randomly pick a number between 1 and 10 to get the first group, and then we add 10 to that each time, and we keep going. Okay, so if I had 400 jelly blubbers and I still wanted 10, then it would be 40 and 1 through 40. So it just kind of depends on what your initial population size is and what you want your sample size to be. Divide those two, and that gives you an indication of where to start, and then you just keep going in that amount each time. All right, last 30 seconds. Most people have typed in. What we're going to see on this graph is a lot of dots that are clustered together and in a space, and then clustered together in a space, because the limitation to systematic approach, especially with this one, is there's only 10 possible different samples we can take. That's it. We've now taken all of those nearly infinite amount of samples we could have taken before, and now there's only 10. So depending on if you got a 1, a 2, a 3, whatever for your first number, that dictates the rest of your sample, and so that's it. There's only 10 possible outcomes to look at. So that would be a negative to this one. All right, so let's look at the graph. A couple last people can still type in as we're doing this. Here's our graph here. So remember our last one, we were really happy, at least I was, of the graph being really tight, clustered together. That's what we want. Now we got a little bit more variety back in it again, and also we have limited information. So whoever got this sample size with 11, there was 3 people that had 11 as their average. One person had this one. We had 3 or 4 people with this number, a couple people with this number. I'd say 2 or 3 had 19 as their average. Again, 2 or 3 had this number. 1 had that one, and then a bunch of people had 24. So we're limited on the amount of information we're getting now because we're eliminating possible combinations. So we only have 10 possible outcomes. So that to me is the biggest negative of this type of graph. And we're going to talk about all the positives and negatives in the next couple of classes. All right, so the last one we need to practice doing so that we're familiar with how it works is cluster sampling. So that one is using the orange sheet. So this one goes pretty fast too, because you only have to use the random generator twice. So what you're going to do is choose 2 random numbers between 1 and 20. So what we've done, if you look at the orange paper, is we've taken all the jelly blubbers and we've kind of broken them into groups of 5 based on where they are on the page. That's it. So the jelly blubbers themselves are not randomized. The locations of where they're at are. And inside those little dotted groupings is a rectangle. It's hard to see, so you might need to zoom in. That corresponds to that group number. So like this group here is 1. There's a little rectangle there that says 2, little rectangle there that says 3, etc. So go to your random generator. There's 20 groups. So between the numbers 1 and 20, you need to pick 2 numbers at random. So I need to pick 2 groups to survey. So I'm going to pick rectangle group number 5 and 13. So go to my sheet. Group number 5 is right here. So I write down all 5 of these jelly blubber numbers on the first part of my chart there. So 27, 37, 38, 39, and 28. So those 5 are picked first. The other group I got picked was 13. So I come down here to 13 and I do 59, 69, 70, 60, and 61. So those will be my 10 jelly blubbers. 5 from one group and 5 from a second group. Go back to using the first chart to get their links. You don't need the smaller charts anymore. Once you get it all figured out, add up all 10, divide by 10, type in your average. Let's see what this one looks like. So this is random based on the location that they happen to be at on the page at that given time. So the individuals are no longer randomized, but the location is. And so it's still random, but it's randomizing a different part of it. All right, so I'll give you guys, again, another 3 or 4 minutes on this one because you got to figure out all your numbers. So take your time. This is our last one we're going to look at. All right, very good. We got about a third of the, or half of the replies in, sorry. So we got about 14 of them done. Give you guys a few more minutes. Cluster random sampling based on location, not on individual randomness. All right, we've got most people done. One more minute. Type in your final answer. Then we can compare this one to the others, and then we'll talk about some advantages and disadvantages of each, and then we will be done for the day. We will not identify the sampling design. That'll be part of our warm-up / review on Friday. All right, so let's look at the last bit of data here on this graph. So not as good as this one. This one's still our best one, but it's a little bit better than the last one just because the location gives us a better randomization than just doing it systematically. Plus, we get a little bit more different possible samples from this one. But again, the averages are coming out fairly good as far as what we're looking for. But we do have more of that range or variability inside of my data than I'd be happy with. So it's anywhere from 12 to 27. Again, for our specific example here, doing the jelly blubbers, this one was the better one because it made everything really centrally located. So that's the one I would want to use in this type of scenario, but not always is that possible. Again, if these fish are actually alive and I'm at the lake, then I can only catch what's right there next to me, right? I can't sit there and be like, oh, I got to put you guys in this group, and because I don't know all the different groups if I'm going to the lake and doing it. So just because one method appears to be better doesn't mean I can always use it. That's what I'm trying to say. That's why we have these other methods here. So anyways, the whole idea behind this activity is to give you guys a little bit of a hands-on feel for how these survey methods work. Some are a little bit more tedious, some are a little bit more accurate. So let's talk about the advantages and disadvantages, and let's go ahead and talk about what the actual answer is so you guys can close down the Peer Deck activity. Let's go back to the slides and look at the actual answer for these. So we selected our 10 jelly blubbers in different ways, from what we thought was representative to what our random processes told us how to select them. And for each one of the samples, we found a different average. And so if you want to check how accurate yours was, your final average was 19.41. So when Alora said at the beginning she got 19.3, I about like went, whoa. That's a very good eyesight judgment test to get 19.3 when our actual number is 19.41. So very good, Miss Alora. Your eyes are good. You don't have to stress so much about your judgment on picking random sizes. I was like, did she look ahead? So no, she didn't. She was over there working. So. But that's the actual answer. So if you wanted to go and take that big chart of all 100 of them, add up all of those numbers, divide by 100, that's what you get. But that's a census. That's a little bit more time consuming. And again, if these jellyfish were alive and floating around, you wouldn't be able to do that. Okay, so sometimes we can do that, sometimes we can't. So let's talk about real quick multi-stage sampling and then a little bit about the advantages and disadvantages of each, and then we'll wrap up for today. So the nice thing about multi-stage sampling is number one, we don't use it much in our AP class setting, so you don't have to panic about it, but it's basically combining different methods together. Okay, so I want to do a little bit of stratified, but I also want to do some clustering with it because maybe I can't pick them based on size or something like that. So it's any combination of different sampling techniques. You go in order and select successively smaller groups within the population and stages. Again, it's not used very much in AP Stat because of its large amount of options, but if you guys are liking this class or you're going to go on and do something statistics related somehow, you might run into it in college and or real life. Right? So we're not limited to just those 4 only, and that's it. We can mix and match as long as the process itself is still being randomized, then we're okay. That's the main goal behind it. So maybe I want to, do the whole country or something, but obviously the whole country is a very daunting task. So I break it up in like different age groups first. And then from the age groups, I decide to, systematically do this. And then from the systematic stuff, I then go back later and maybe I take some random samples in a smaller portion or whatever. So I could stack these different methods on top of each other and get to the type of population I want. And because I'm doing it random each step of the way, then it would still count as a random sample. So like everything in life, there is a way to complicate it, but we're going to stick with the basics and the simplicity of it as we're learning through this. Okay, so let's talk about advantages and disadvantages of each. Using multi-stage approach to the high school students, we could first divide second period classes into different types of classes, AP, IB, regular, etc. Then randomly select 4 class periods from that group, and then randomly select 5 students from each class. That's an example of multi-stage sampling. So the first one was clustering based on second period. Then I broke them into groups by stratifying which type of class it was, and then I did a systematic random sample, not systematic, I'm sorry, I did a simple random sample from each class because I didn't want to do everybody in the class, I just wanted to do 5. So that would be an example of multi-stage sampling where I'm mixing all of those together. It's in your notes already, so you don't have to worry about writing it down. All right, so advantages of the first method, just the basic old simple random sample. There's no bias to it. So as good as Alora was at guessing, the simple random sample would not let her use her expert skills. She would have to be as equal as the rest of us in picking the 10. Okay. It's easy to design. You just need to tell yourself how many people you want to pick and start picking them. And then later on, when we start talking about formulas for standard deviations and confidence intervals for this stuff, it's a lot less complicated. Now, there are some disadvantages. You're going to have some variability issues like we saw on our activity. So it's possible to get some really big samples or really small samples. It's not always representative of your group because remember, not only does each individual have the same chance of being picked, but so does each group. And the biggest disadvantage, like I said earlier, is you have to have that sample frame. So if I don't have a clue what my population is in total, I can't even use this method effectively correct. All right, advantages, disadvantages. So each one of these methods are going to have good things and bad things. So you have to decide what works best for you. Now, Laura, I'm complimenting you on that, yes, because that was one of the closest ones that I've gotten from somebody. Yeah, just, there's been some others very close like that, but it's in that group of like top 5 or 10 that would just eyeball testing and like, oh, I didn't got like 19 point something. So very, very good job. Either you were very lucky or very good. It doesn't matter which way. You were very close. All right, so that's simple random sample. What if I do the stratified one where I break people into groups first and then I randomly sample them that way? Well, the advantage are that it's still unbiased. Yay, that's what I want. There's a lot less variability, meaning it's a much more precise, accurate measurement of the population. We saw that with the Peer Deck activity, that the numbers got really close together. And if your strata already exist, then this is actually very easy to do. So for our jelly blubbers, they were already in sizes. That was nice. If I'm surveying high school students, you guys are already in different groups, all right? Grade level, class level, whatever. GPAs, gender, all that stuff is already identified for you, so I don't have to go back through and actually do anything. Now, disadvantages. Number one, it's difficult if you have to be the one to make the groups because then you have to decide how to do it. The formulas are way more complicated because there's ones for each group. And again, you're going to need that sampling frame. If I don't have a clue what everybody is in the population, I definitely can't use this one. So you guys saw how tedious it was to do the 1, 2 by 2 by 2. You had to go through and do it all for each group. So that also would be a disadvantage as well. A lot more time consuming. Especially again, if you have to be the one that divides the groups up. And the groups need to be divided to where everybody in that group has something similar or very much the same. All right, so simple random sample, stratified random sample, pretty much the same method, except for stratified, you go ahead and group everybody first. That's really the only difference between the two. Now, let's talk about the ones that are a little bit weird, a little bit wonky compared to these two methods. But the nice thing about the next two is you don't need to have the sampling frame, and that's why they exist. All right, so for systematic, here's the advantages and why they use it at the airports and stuff. Again, it's still unbiased officially. Number two is the main reason why you would use systematic. There's no need for a sampling frame. And your time spent on it is easier and more efficient. So if I just randomly pick a number between 1 and whatever, and I interview every if person after that, then there's no thinking on my part. It's just, hey, you're next. Count, count, count. Hey, you're next. And keep going until I get enough people. So the advantages are on the prep work and the upfront end. Disadvantages, however, there's a lot more variability. It can be confounded by a trend or cycle. So what I mean by this is, what if I am doing a systematic approach in the hallway, and the only students that are using the main hallway are the ones that want to talk all the time to their friends, whereas the smart kids go upstairs, use the back stairwell, get around everybody, right? So I'm going to miss all those people. So there's a trend of only the people that are crazy enough to walk in front of G hall, F hall, and A hall during passing periods are the ones that want to go meet all their friends or watch a fight, right? The other kids are like, screw this, I'm going upstairs, I'm walking the back way, whatever. And so I could be confounded by missing out on somebody. Formulas for this would also be much more complicated because I got to sit back and try to figure out, okay, so this person was this guy and this person was this guy and that kind of stuff. So there are some issues with the systematic one. At the airport, they're disadvantaged by confounding would be like, what if the flight is going to a particular location? Well, then everybody that's going to that particular location feels like, why are we being, interviewed? When later on people are going to a different flight and don't even get bothered. So there's a complete flight that may even not be randomly screened outside of the normal security because they all came in at a different time, went to a different gate, whatever. All right, so systematic, easy to do up front, leads to some issues on the back end, but the main advantage is I don't need to set up a sampling frame. I don't have to have one. I can just start randomly interviewing people as I run into them. So that's why it's used. It's still random, so therefore it's still unbiased. Notice that's the main thing on each one of these. Unbiased, unbiased, unbiased. So we're going to talk about bias next class. So you need to be able to eliminate bias. Last one, cluster sampling. So advantages, again, unbiased. Why? Because it's random. You don't need your sampling frame again. Hooray. That's why we do it that way. And it's easier and more efficient. So very similar to the systematic one. However, disadvantages here include more variability. Clusters may not be representative of the population. And again, my formulas are complicated to do. So we'll talk about more of that as we go throughout the year. But the biggest disadvantage for the cluster one is the second one. If I'm only interviewing random class periods during second period, what if that's the class period that like all of the, I don't know, seniors have some sort of like class meeting going on or something that day. So I get 0 seniors in my meeting. So I may not be representative of my stuff. So we're ending here today. We've talked about the different types of sampling methods and why we sample, because our censuses are typically trash, as in they're not accurate and time consuming. So we only want to take a small portion of the population in order to find out information instead of the whole population because it's expensive and takes too long. But with that being said, that leads to new challenges, which is how do we sample in such a way that it still represents the population that I would normally count? And so we have to be careful. We can't just eyeball test it or do our favorite things. We have to find a randomized approach that takes all of our bias out of the equation. So next class, we're going to talk about why the bias is bad. It's a very interesting topic and discussion. It's very relevant to today's time. So I hope you guys are looking forward to that. You may not, you may be completely tired of school already, and that's fine. But I'm very excited about Friday because we're going to talk about what goes wrong with your samples and what can cause issues. So it is a discussion-friendly class if you guys want to discuss things or talk about sampling methods and all that. As far as action items for the rest of the day, so Zoom people, if you got your grades squared away, then you're good. If not, then continue to email me things like you guys have been doing it during class. I got a couple people that have already emailed me. I got to unlock tests and stuff for them. So I will get to doing that as soon as class is done. Thank you for letting me know. But make sure all your Unit 2 stuff, Unit 1 stuff is done and turned in so I can get those updated in the grade book. It's going to take me till this afternoon to do it, so be patient, but I will get there and get her done. Everything for Unit 3 is on the next 9 weeks, so you don't have to worry about being anything due by this Friday or anything for Unit 3. So I will see you guys on Friday. If you have any questions, sign up for tutoring, email me whenever, Zoom, and we'll talk then. You guys have a good rest of your day. We'll see you on Friday. Any questions, guys? Thank you, Ms. Clay. Laura, did you want to talk about your thing? You want to wait till the bell rings and then we can talk about your the what you were trying to meet me in? Yes, sir.
Can you update my FRQ history with 2 points?
Yes, sir. You said FRQ, right?
Yes.
All right, I got you. Give me just a little bit of time. I'll get that done for you. Okay, that's for, gotcha. What is this one? Yes, I'm having trouble with it. It just says it's closed and all I can do is use.
Ladies and gentlemen, please stand and pause as we begin the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands,